Okay, so I'd like you to work on this warm-up. Number 1 is part of our systems essential skill. It was on the test you just took. See if you can graph those correctly and remember everything that it entails. Remember, in our notes, it was a warm-up. We actually did one of these problems where we literally talked about every single point that it was worth on test day. And then test day rolled around and a lot of you came up and asked me, do I have to shade? And I told you, this is what it's going to look like on the test. It's just going to say graph. The symbols mean you have to shade. And I can't tell you that on test day. I need you guys to remember that on your own. So make sure that you are shading and looking for dotted and solid on number 1. So you should pause your video and see what you can get. So if I start graphing the top equation, that has a locator point at 1, 3. And it is negative, and it's a parabola, and the a value is down 2. So down 2 on the left, down 2 on the right. And then before you connect the dots, stop and think whether it should be solid or dotted. This one should be dotted because there's no equal to bar. And then you can test a point. 0, 0. I'm not going to test 0, 0. I can't really tell if that's inside or outside. And I also think now's a good time to show you guys the shortcut. So first of all, you could test 1, 0 if you'd like to. I would let you know ahead of time that's going to come out to be true if you do all the work to test 1, 0. But also, if you look at this symbol, this says y is less than your equation. So if you put your pencil at the locator point of your equation, where are the smaller y's? Are there smaller y's up the y-axis, or are the smaller y's down the y-axis? They're down. So you're going to shade down lightly from the locator point. Or you test 1, 0 and it comes out to be true, and that's why you shade that side. So just a little shortcut for those of you that are ready for a shortcut. Then I'm going to graph the second equation. -1, -1 for the locator point, opposite of both. Radius of 3, square root of 9 is 3. 1, 2, that's not 3. 3 left, up, right. I did it backwards, sorry, you know what I mean. 3 in every direction. When I connect this dot, it is a solid line, because when you see a solid line, an equal to symbol, you connect with a solid line. Remember, shortcut for this one is to test the center, which was -1, -1. When you do that, it's always going to make the part with the variables 0. And then alligator's supposed to be eating the bigger number. It's not. So if the inside's false, the outside is true. Lightly with pencil. And then as you're doing that, where it overlaps your other shading, you need to make it extra dark. Those of you who did not make it extra dark on test day, where they overlap, did not get full credit. That's the solution. So if you don't make it extra dark, you're not going to get full credit. Okay, pause the video and see if you can write one biased and one non-biased question about having 2 lunches. And what I mean is, you know how we have first lunch and second lunch? Obviously, people are going to have opinions about that. So can you write one question that's obviously biased and one question that's clearly not biased about that? Pause the video and try it on your own. So for biased, we want it to be obviously biased. The easy ways to make things obviously biased is to include extra information, whether it's positive or negative information. That would make it biased. So let's see. Having 2 lunches this year means the line to get lunch is shorter. How do you feel about having 2 lunches? So that influences the person. Or having 2 lunches this year means you don't always have lunch with your friend. How do you feel about having 2 lunches? So that influences the person the other way. You have to explain it. I can't even tell you how many of you are going to forget to explain it and lose 1 out of 3 points on this question. So it's biased because I gave them extra information, or whatever it is you want to say. Then for your non-biased question, we want to be short and sweet and open-ended. So what are your thoughts on having 2 lunches this year? As simple as that. So keep it short and simple. What are your thoughts on whatever the topic is? Okay, for our notes today, we are on page 3. We're going to talk about observational study. So observational study, this is a vocab word you're going to need to be able to use and know. It is a study where data is collected by observing an existing situation without the researcher or observer imposing any type of change or treatment. So you're just watching something that's already happening. You are not like making them take a pill or forcing them to work out twice a day or anything like that. You're not forcing anything. You're not imposing any change. You are not without imposing any change or treatment. So the one thing about observational studies is you can never conclude an association based on cause and effect because there's so many other variables out there that might be affecting it. So a lurking variable is a hidden variable that was not part of the statistical study under investigation, but sometimes the lurking variable explains the true cause of an association between two other variables. So this goes with above. Observational studies are often plagued by these. So here's two examples. In an analysis of damage caused by house fires, it was found that the more firefighters that are sent to a fire, the greater the damage. So are the firefighters causing damage? So this is like a true statement. The more firefighters you send to a scene, the greater the damage. So based on that statement, we should stop sending firefighters to the scene, right? Because clearly they're causing the damage. Well, we know that's not true because there's a lurking variable, just LV for lurking variable. And it's up to you to tell us what that lurking variable is on test day. It's a third factor, right? It's nothing written in there already. It's something else that's causing both things. So what's causing me to send more firefighters and causing greater damage? Well, a bigger fire is causing that. The lurking variable is a bigger fire. That's all you would need to say, but here's why. A bigger fire causes more firefighters, and a bigger fire also causes more damage. It's a third outside lurking variable that's causing those things. Let's see the second example. Weekly ice cream consumption and murder rates are highly correlated. So does ice cream incite murder, or does murder increase demand for ice cream? So clearly neither one of those things create the other. There's a lurking variable. And this one's kind of vague. You might not know this, but it's heat. If it's hot outside, people buy more ice cream. And studies show if it's hot outside, people get mad easier and might commit murder, right? That one's a little vague. I want to tell you another one verbally, so I hope you're listening. And these are true things, and we need to find their lurking variable. So this one coincidentally has ice cream in it again. So here's a true statement. The more ice cream that is sold, the more shark attacks that are documented. So clearly we should stop selling ice cream, right, to avoid shark attacks. Well, no, because those two things aren't actually related to each other. What's the lurking variable? And there might be more than one lurking variable, but they're all kind of related. The lurking variable is summertime. When it's summertime, more people buy ice cream. When it's summertime, there's more people in the ocean, therefore more shark attacks. Or you could have said it's hot outside. Or you could have said you're at the beach. More people buy ice cream at the beach, and obviously shark attacks happen at the beach. So being able to find a third outside variable that is causing both of those things. Okay, kind of the opposite of observational study, and also a vocab word, is experiment. An experiment, subjects are randomly divided into two or more groups, and a treatment is imposed, right? That's the opposite of observational. You make them do something, you give them a drug, you do something to them. Kind of in the same idea, a placebo is a treatment with no effect. A lot of times it's a sugar pill, so you've got this experiment, you're giving everyone, or you're giving half the people, Tylenol every day. You want the other people to think they're taking Tylenol every day, so you give them what's called a sugar pill, a fake pill that actually has nothing in it. But at least then the participants think that they're in the same treatment group. So they don't know, they're not even giving me Tylenol. They think they're getting the Tylenol too. So here's a big thing. Observational study or experiment. We need to be able to do this on test day. This is why you need to know the vocab words. I made that yellow, right? Okay. Number 1, in a test of roughly 200 men and women, those with moderately high blood pressure, averaging 164/89, did worse on tests of memory and reaction time than those with normal blood pressure. Do we think this is an observational study or an experiment? Pause the video and write down your guess. So the question is always about treatment. Did they do anything to those people? Well, no, these people just showed up with high blood pressure. They didn't give them high blood pressure, right? They already had it. So this is observational. They already had high blood pressure. They did not impose a treatment. The next one, over a 4-month period among 30 people with bipolar disorder, patients who were given a high dose of omega-3 fats from fish oil improved more than those given a placebo. So as soon as you see they were given something, they were given a pill, a fish oil pill, this is an experiment. So, in order to perform a correct experiment, a completely randomized experiment, here's a little flowchart of how you do that. You take your subjects, let's just say there's 100 subjects, right? We're just making numbers up, which is fine. You split them evenly. One group gets a treatment. Maybe that's a pill, maybe they're forced to work out 20 minutes a day. The other group either doesn't have to work out 20 minutes a day, or they get a placebo pill instead, and then you compare the results. So this is how you run an experiment. Down here, assign subjects randomly to the treatment groups, give them the appropriate treatment, and after a specific amount of time, look for the difference. So find the blank spot in your note packet. We are going to describe how to design an experiment about how vaping affects lung health. So how would we do an experiment about how vaping affects lung health? Well, here's what we would do. We would take 100 people. Again, the numbers aren't as important. Bigger amounts is better results. I would make 50 of them random, take 50 of them randomly, and the other 50 randomly. These ones, I would force them to vape daily for 2 months. These ones, I would make sure they're not vaping. No vaping allowed for 2 months. At the end, I would somehow compare their lung health. Usually that's when they put you on a treadmill in the hospital and gauge your breathing or whatever, your O2 levels. So this is how I would design an experiment. Split them up evenly, impose a treatment. Forcing them to do something is imposing a treatment. Don't let the others do the same thing, and then compare their lung health. Here's the thing though, is this ethical? Can I take 50 people and force them to vape for 2 months? No, this is completely unethical. So sometimes an experiment is not ethical or possible, so you have no choice but to do an observational study. In this example, I would go find people who admit to vaping and compare their lung health to people that I find that are not vaping. So you can't force people to do it. You can't always do an experiment. Sometimes you need to do an observational study instead. Okay, those are the notes for today. You know you have bookwork that you need to do, which is on Schoology again because there's no numbers, so you can just type your answers right into Schoology. And you also know you have to do the second page, review 2, which is just a single page in that review packet.